The Invisible War. The year is 1991. Baghdad sleeps under a moonless sky. In concrete bunkers buried beneath the city, radar screens glow with nothing but static noise. Empty sky. The equipment is among the most sophisticated in the world, designed to detect threats hundreds of miles away. Then the city explodes. Communications towers vaporize in brilliant flashes. Command centers collapse into rubble. Surface-to-air missile sites erupt in secondary explosions. The destruction is methodical, surgical, devastating. Yet the radar screens remain unchanged. Empty sky, no aircraft, no threats, nothing. The equipment functions perfectly. Every circuit tested, every frequency scanned. But the evidence of vision contradicts the evidence of instruments. Baghdad is being systematically destroyed by an enemy that does not exist. At dawn, urgent encrypted messages flow to Moscow. The reports are identical from every location in Iraq. All radar systems operational, all frequencies monitored, zero aircraft detected. The implication is incomprehensible. America has deployed a weapon that Soviet technology cannot perceive. 17 years earlier, in 1974, the story began not with metal and engines, but with mathematics. Deep inside Lockheed's Skunk Works facility in Burbank, California, an impossible challenge emerged. The Pentagon demanded an aircraft capable of penetrating deep into Soviet territory without detection. Not an aircraft that was difficult to track, an aircraft that was invisible to radar. An obscure paper published in 1962 by a Moscow mathematician provided the answer. The paper explored how electromagnetic waves interact with geometric surfaces. To Soviet military planners, the work appeared purely theoretical, with no practical application. They published it openly, considering it scientifically interesting, but militarily useless. American engineers saw something different. The equations revealed a profound truth about radar detection. Radar works by sending electromagnetic waves that bounce off objects and return to a receiver. The mathematics proved that specific geometric configurations could deflect incoming radar waves away from their source, scattering them into space rather than reflecting them back. The principle was counterintuitive. Aviation design for 70 years had pursued smooth curves and streamlined shapes. The mathematics suggested the opposite: sharp angles, flat facets. Surfaces precisely calculated to redirect radar energy anywhere except back to its origin. The aircraft wouldn't hide from radar. It would trick radar into looking elsewhere. Design work began on an airframe built entirely from flat, angled surfaces. Each facet precisely oriented to deflect radar waves. No curves anywhere. The result looked like a geometric nightmare, something assembled from broken mirrors. The design resembled a diamond viewed from above, sharp and angular. The appearance suggested fundamental incapability of flight. But the calculations were undeniable. A conventional fighter aircraft presents a radar cross-section comparable to a large automobile. This design reduced that signature to something resembling a ball bearing. On radar, it would appear smaller than a bird. One critical problem remained. The angular design was aerodynamically unstable. The aircraft would not naturally fly straight. No human could make the thousands of tiny corrections per second required to keep it airborne. But technology had advanced. Fly-by-wire computer systems could process inputs and make constant micro-adjustments to flight surfaces, maintaining control through digital intervention rather than natural stability. In 1977, a prototype lifted off from a remote Nevada test range. For 36 minutes, it flew in controlled airspace while radar stations attempted to track it. The screens remained empty. The aircraft performed as theory predicted. Full production authorization came immediately. The security protocols were absolute. Every aspect of the program became compartmentalized. Workers manufactured components without knowing their purpose. Different facilities produced different sections. Final assembly occurred in buildings that appeared on no maps. Records were erased. Families were told nothing specific. No photographs, no discussions, no acknowledgement of existence. The first production aircraft rolled out in 1982. For 7 years, it flew exclusively at night over restricted military ranges. The Air Force refused to confirm the program existed. Aviation journalists speculated, but official sources denied everything. The aircraft remained invisible, not just to radar, but to public knowledge. The aircraft handled poorly. Comparisons were made to flying a garbage truck with wings. It could not dogfight. It could not outrun threats. It carried no defensive weapons. Its sole advantage was invisibility. When approaching enemy airspace, radar operators saw empty sky. And in modern warfare, that advantage proved decisive. August 1990. Iraqi forces invaded Kuwait, seizing control of the small oil-rich nation within hours. The United Nations condemned the invasion. The United States assembled a massive coalition force in Saudi Arabia. Operation Desert Shield became the largest military deployment since Vietnam. Iraq's military was formidable, fourth largest army in the world, battle-hardened from 8 years of war with Iran, air defenses among the most sophisticated outside the Soviet Union. Soviet advisors had spent years building an integrated air defense network modeled on the systems protecting Moscow. Multiple overlapping radar zones, hundreds of surface-to-air missile batteries, thousands of anti-aircraft guns, electronic warfare stations, command and control bunkers linked by redundant communications. On paper, the system appeared nearly impenetrable. War games predicted that any conventional air campaign would suffer catastrophic losses in the opening hours. American planners possessed a weapon Iraq did not know existed. 42 stealth aircraft, maintained in absolute secrecy. The aircraft arrived in Saudi Arabia under extraordinary security measures. They flew only in darkness. Ground crews worked inside closed hangars. Even coalition partners were not informed of their presence. The mission planning was audacious. These aircraft would strike first, alone, without support. No electronic warfare jamming, no fighter escorts, no diversionary attacks. They would fly directly into the most heavily defended airspace on Earth and destroy Iraq's entire command and control infrastructure in the first 3 hours of war. If successful, the integrated air defense network would collapse into isolated fragments. If unsuccessful, coalition forces would face a coordinated defense system capable of inflicting devastating losses. January 16, 1991. Night fell over Saudi Arabia. At air bases hidden in the desert, final briefings concluded. Weather conditions, clear. Enemy alert status, maximum. At 11 o'clock that evening, engines started. One by one, the aircraft rolled down darkened runways and climbed into blackness. January 17, 1991. 2:51 a.m. Baghdad time. The first aircraft crossed into Iraqi airspace at high altitude. Baghdad's air defense network operated at full readiness. Radar operators monitored their screens with disciplined attention. Training had prepared for this moment. American attack was expected, but the screens showed nothing. Empty sky, normal atmospheric interference, no threats detected. At 2:51:23, a massive explosion tore through Iraqi Air Defense headquarters. At 2:51:29, the central telecommunications facility disintegrated. At 2:51:37, 3 separate command bunkers exploded simultaneously. Precision-guided bombs struck with devastating accuracy. Yet radar screens showed no incoming aircraft, no threats, empty sky. Equipment showed no malfunctions. Every system operational, every frequency monitored. But every few seconds, another critical facility vanished in fire and smoke. The evidence of instruments contradicted the evidence of reality. Something was destroying Baghdad's military infrastructure with surgical precision, but that something did not exist. Iraqi interceptor aircraft scrambled blindly, given no target coordinates because radar detected no targets. Surface-to-air missile batteries fired at empty air, guided by desperation rather than data. Anti-aircraft artillery opened fire on nothing, tracers arcing into darkness, hoping to hit something, anything. The city erupted in defensive fire against an invisible enemy. Thousands of rounds expended. Nothing hit. By 3:30 a.m., Baghdad's integrated air defense network had ceased to function as a coordinated system. Command bunkers destroyed. Communications severed. Radar stations isolated. The network had collapsed into fragments. At 3:35 a.m., hundreds of conventional coalition aircraft swept across the border. They encountered an air defense system without command, without coordination, without effective response. The stealth aircraft had opened the door. The conventional force poured through. Over the following hours, increasingly desperate reports flowed to Moscow. American stealth technology had surpassed all intelligence estimates by at least a decade. The radar networks defending the Soviet Union were obsolete. American aircraft could strike anywhere within Soviet territory, and Soviet defenses would see nothing until bombs exploded. The implications were catastrophic. The war continued for 42 days. The stealth aircraft flew 2% of total sorties but struck 40% of strategic targets. They operated with complete impunity. Iraqi forces fired over 2,800 surface-to-air missiles during the war. Not one came close. Not one aircraft was damaged by enemy fire. The perfect record. In Moscow, military analysts studied the reports from Baghdad with growing alarm. For decades, Soviet military doctrine had relied on integrated air defense networks. Massive investments in radar technology, surface-to-air missiles, interceptor aircraft. The strategy assumed detection preceded engagement. If threats could not be detected, the entire defensive structure became meaningless. American stealth technology had rendered billions of rubles in military infrastructure obsolete overnight. Soviet air defenses, once considered among the world's most formidable, could not stop an enemy they could not see. The psychological impact was profound. The most advanced technology failed completely against an invisible adversary. The aura of Soviet military might, carefully cultivated for decades, evaporated in 3 hours over Baghdad. The demonstration was global. Television networks broadcast images of Baghdad's night sky filled with defensive fire, tracer rounds, and missile contrails illuminating darkness, all of it aimed at nothing. The world watched a sophisticated military power fire blindly at empty sky while facilities exploded. The message was clear. American technology had achieved a decisive advantage. Soviet systems could not compete. Military analysts concluded that the Cold War had been lost years before anyone realized. While the Soviet Union built larger missiles and heavier tanks, America invested in computers, precision guidance, and stealth technology. The balance of power had shifted invisibly. The revelation came too late. Economic pressures had been mounting for years. Political reforms had destabilized the system. But the psychological impact of technological obsolescence accelerated the collapse. When the most advanced weapons fail completely, when military doctrine becomes irrelevant overnight, when the world watches defenses prove impotent, that represents more than tactical defeat. It represents the end of credibility. By December 1991, the Soviet Union had dissolved. The causes were complex, rooted in economics and politics and ideology, but the image endured. Soviet military technology, once feared across the globe, firing uselessly at invisible enemies. The demonstration of American technological superiority could not be denied or rationalized away. The stealth aircraft flew 1,269 combat sorties over its operational lifetime. Not one was ever damaged by enemy fire. The perfect record stands unmatched in military aviation history. Only once, in 1999 over Serbia, did an enemy successfully engage a stealth aircraft. Unable to detect the aircraft on radar, air defense forces studied flight patterns and positioned missiles along a predicted route. When the aircraft appeared, flying the same path at the same time, missiles launched at close range. One hit. The aircraft went down. The incident proved that stealth was not absolute invincibility, only profound advantage. But it required exceptional skill, detailed intelligence, and considerable luck. The aircraft was officially retired in 2008, replaced by more advanced systems. Some remain in flyable condition, maintained by small crews preserved against uncertain futures. The Soviet mathematician whose equations made stealth technology possible immigrated to America. Work continued in the aerospace industry until death at 93 in 2021. When asked about regrets regarding Soviet planners not recognizing the work's practical applications, the response was simple. Mathematics belongs to no nation. Equations do not care about politics. But acknowledgement came that if Soviet leaders had read the papers more carefully, history might have unfolded differently. The stealth aircraft did not cause the Soviet Union's collapse, but it revealed that the collapse was already underway. It demonstrated that while one superpower invested in theoretical research, computer technology, and innovative engineering, The other had fallen behind in ways that could not be quickly remedied. The gap had grown too wide. The advantage too decisive. Empires do not fall only from economic strain or political upheaval. They fall when the perception of power dissolves, when military might proves hollow, when advanced technology fails against an enemy that should not exist. The psychological dimension of defeat often proves more decisive than material losses. For 17 years, these aircraft flew in complete secrecy, invisible not just to radar but to public knowledge. In that time, they shifted the balance of global power, not through nuclear threat or massive armies, but through the simple fact that they could strike anywhere and no one could stop them. Innovation, secrecy, execution. The three elements combined to create a weapon that changed warfare, not through destruction, but through psychological impact. The demonstration that one side had achieved technological superiority so profound that conventional defenses became irrelevant. The aircraft flew in darkness, invisible and untouchable, and when the bombs started falling, when the invisible became devastatingly real, it was already too late. The war was over before anyone realized it had been fought. Thank you for watching. We uncover declassified Cold War secrets every week. Subscribe to Cold War Black Files so you never miss a story.